Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. Okay, next question. I have the integral of, in the numerator I have 4x squared. In the denominator I have quantity x cubed plus 1, and that's all going to be squared, okay? So once again, it's a U-substitution problem. How do I know? Well, it's just a mess, and plus we clearly have a quotient rule and a chain rule going on here. So I need to choose a U for my U-substitution. What should I choose? I'll give you like 5 seconds to take a guess on your own. Don't say it out loud. And the correct answer is x cubed plus 1. Pretty similar to the last one, so hopefully you got it. And if not, no big deal. We'll talk about what to do when you get it wrong in the next problem, but for now we're still right. We're 100% accurate. And the next step after you choose your U, we need to solve for dx, which I actually forgot to write in the problem. There we go. So to find dx, I need to say du dx, my derivative, is equal to the derivative of x cubed plus 1, and the derivative of x cubed plus 1 is just 3x squared. Now once again I need to solve for dx, so I multiply both sides by dx. Du will equal 3x squared dx, and then divide by 3x squared. Dx is going to equal du divided by 3x squared. I'm going to plug in the dx right there, and I'm also going to plug in my u, x cubed plus 1, right there in the denominator. So what does my integral look like then? It's going to look like, what do I do with the 4x squared in the numerator? Nothing. I leave it alone. I hope it cancels out. In the denominator, I have u squared now, and dx just got replaced with du over 3x squared. So similar to the last problem, the x squareds will cancel out. The 4 and the 3 do not cancel out. They are going to be written out in front of the integral as 4/3 as a coefficient times the integral of 1 over u squared du. Now we're still not ready to take the integral yet because that u is in the denominator, but the reason how I know I chose the right u for the u substitution is because, do I have any x's left over in this integral? No. And that's how I know I chose the right thing. If I chose the wrong thing, I would have x's left over. It'd be no good, and we'd have to start the problem completely over again. Very fun when that happens. Okay, so before I take this integral, I need to rewrite it as u to the negative second power du. There we go. And so then I'm going to say this is equal to 4/3 times the integral of u to the negative second power. Again, I need to add 1. So it's u to the negative first power divided by negative 1 plus c. Again, I can rewrite that if I want to now as negative 4/3 times 1 over u plus c. And the last step, of course, is to say, what is u? U is going to equal x cubed plus 1, so there we go. We get a final answer of negative 4/3 times 1 over x cubed plus 1 plus c. And there we go. Any questions on that one?
How did we go from the du to the c?
Let me see. Right, you mean at this step, right? Here to the next step?
Yeah.
So just in general, when at this step, I took the integral in the next step. And whenever you take the integral, you lose the integral sign and you lose the du, and it gets replaced with plus c.
Okay.
But that's a good question.
How did?
Because a lot of people forget that, and then you have some people who put du plus c, and those people are just so wrong, it makes me laugh. What were you about to ask?
And then how did we get the negative 4/3?
Yeah, so I kind of it's from this negative 1 in the denominator. I just wrote it out in front.
Oh, okay. Thank you.
Yep.
I'm still kind of confused on how you're getting your, I get that you get the derivative from u, but
yes.
The whole du over dx thing is, how'd you get du on the top over 3x squared?
I want to know where I'm losing you with this. So this makes sense, I'm assuming. Does this step make sense?
Yeah, the first derivative does.
Okay, now, we've never seen this before because, well, we never had to do it. But du dx can actually be broken up, even though, why would we do that? This is the derivative. We're breaking it up right now because we need to solve for dx. So what I did was I multiplied both sides by dx. The dx is canceled there, and I still had to multiply dx over here. That's how we got here. And then what did I do? I divided by 3x squared on both sides.
Okay, that makes more sense.
Good. Any other questions? So now, as promised, the next one I'm going to purposely mess up because I could not make a mistake unless I clearly tried to, because I'm perfect. That's usually not true. Whenever I say that, it's usually within the next 5 minutes I actually make a mistake, not intentionally. So I need to be careful about bragging in that way. I've been pretty good this semester, though. I haven't been bragging that much. That's probably not true. For those of you who know me well, yes, I brag in every lesson. But I deserve it. I'm the best. So it's not bragging, it's the truth. Okay, so now with this one, again, I'm going to purposely choose the wrong thing. Also notice that, well, for this integral, 2x plus 2 times quantity x squared plus 2x, technically we don't even need a U-substitution. If we wanted to, we could FOIL everything out and then just do a series of power rules to find this integral. But since this is the U-substitution lesson, I'm going to use a U-substitution. So I need to choose U. Let's say I'm an idiot and I have no idea what I'm doing, and I say U equals 2x plus 2, because that's what I think U needs to be. Then du dx, the derivative, is equal to 2. I should have also warned you from the beginning. Since I'm doing this the wrong way, feel free, instead of writing this down and then erasing half a page of work, if you just want to kind of watch and learn, that's fine too. So du dx is going to equal 2. Again, I need to solve for dx. So I multiply both sides by dx. Du equals 2 dx. And then dx, I divide both sides by 2 to get dx equals du divided by 2. Okay. Now again, I plug in dx right here. I'm going to plug in u right there. We're going to get the integral of u times quantity x squared plus 2x times dx is now du divided by 2. Now, first of all, notice nothing canceled, but that's not necessarily the problem. I don't need stuff to cancel. The bigger problem is just the fact that I have these x's left over that did not cancel out. And since I have x's left over, this is entirely wrong, and I'm going to erase everything I just wrote. Luckily for me, I have my handy-dandy, cheater tools here. But for you, you'd have to cross everything out. It's very annoying. Okay. So this, instead, the correct U-substitution is x squared plus 2x. I'm going to go relatively quickly here since we essentially did this already. But du dx is equal to derivative of x squared plus 2x is 2x plus 2. Then I'm going to say du is equal to quantity 2x plus 2 times dx. I multiply dx on both sides. And then the next step is divide both sides by 2x plus 2. dx equals du divided by 2x plus 2. Now let's see what happens when I plug everything in. I'm going to get the integral of quantity 2x plus 2 times now just u times dx is now du divided by 2x plus 2. We see that the 2x plus 2 will cancel, which is nice. And now we're just left with the integral of u du. This is a very easy integral to solve. It's going to be u squared over 2 plus c. And again, we said u was x squared plus 2x. Final answer, quantity x squared plus 2x squared divided by 2 plus c. Okay. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.